So here's a little simulation I put together. So there's a very nice app on the iPad called Atoms in Motion. And what I have here is a bunch of argon atoms. I got 20 of them at 5 Kelvin. And so you can see at this low temperature, right, essentially the atoms are pretty much stuck together. So if you follow any atom right, it is stuck next to one another. Now I went ahead and recalled a saved state here. So now I'm at 72 Kelvin. And you can see that the atoms now, they're kind of moving over top of one another. So, these atoms here, so if you keep your eye on this one here, it's kind of moving around. And other atoms are sneaking around it. So it's no longer a solid, it's more of a liquid. And I'm now at 975 Kelvin, so you can see that the attractions between the molecules are so much wimpier than the thermal energy. So they literally can't hold themselves together. So now they vaporized and they formed a gas phase. So I've just cooled it down. So now I'm at 4 Kelvin. So notice that the intermolecular forces, the attractions between the molecules are holding them together, and they are tighter than the thermal energy. So they're able to bind and to form those solids there. And as I crank up the temperature, notice that they move around a little bit more. So look at this little cluster here, right? So the atoms are starting to break free. At least they're starting to kind of move a little more violently. I'm at 50, 60 Kelvin. So notice now that the attractions between the molecules are very wimpy compared to the thermal energy. I'm at 100 Kelvin. So notice these guys are starting to become very, very loose. 150 Kelvin, up there breaking free. So at this point here, I have essentially vaporized my sample. So pretty cool, huh?